Okay, ladies and gentlemen.
Sorry.
No worries. If you're not in my class, head on home to your own class. We are going to go to page 20. Page 20. 20.
This video is an introduction to ionic bonds and ionic bonding. Don't know anything about these things, or you feel a little bit rusty?
Okay, let's get our volume set up here. And let's get our screen set up here. Everyone, what page are we on? 20. Where's Arna? Okay.
It's no big deal, because we're going to start from scratch. So, ionic bonds are one type of chemical bond. Chemical bonds are like glue that holds atoms together. Okay, like here are two atoms that are bonded together, they're connected, they're glued. Now, ionic bonds are the type of chemical bond that hold together metal atoms with non-metal atoms.
Okay, so you got one thing to fill in there on page 20. Ionic bonds, what do they connect? They connect metals and non-metals. Excellent.
Okay, so if you look at a periodic table, there's this big, thick staircase over on this side. And this staircase separates the metals, which are all the elements on this side, from the non-metals, which are most of the elements on this side. So whenever we have a chemical that has a metal connected to a non-metal, that's held together by ionic bonds.
And if you're wondering, what about the metalloids? Metalloids behave like non-metals when they are bonding. Okay, you don't need to write that down, but metalloids behave like non-metals, okay, in terms of their bonding. Metalloids behave like non-metals. So if you put a metal together with a metalloid, you will get ionic bonds. Okay.
So some examples are silver chloride, magnesium iodide, or aluminum oxide.
So here we have some compounds. And you can feel free to write down those names. If the font is too small, it was too small for someone who forgot their glasses yesterday, so we have them written up nice and big here. Okay. And what do you notice about the names of the metals? In the compound, yes.
They're all like
the last, yeah, these ones over here, all the non-metals. What color did they make that? They made it green?
Can we take the test?
Yes. There you go. All the non-metals. Are anions, and because they are anions, what happens to their name? Yes, they all change to iode. So when we put sodium together with chlorine, it becomes sodium, or silver rather, silver chloride, magnesium iodide, and aluminum oxide. But what happened to the names of all the metals? Nothing, because cations don't change their names.
Each one of these chemicals have a metal, this one, or this one from this side of the periodic table, with a non-metal, this one, or this one from this side. So, ionic bonds in all these because there are metals and non-metals connected together. Okay, so now we're going to talk a little bit more about the how and why that's going on with the bonding here, right? It's like, how do these atoms actually connect together? What's holding them? That's what we're going to talk about next.
Okay, I would like you to think, what is holding the silver to the chloride, what kind of force would be holding them together? See if you can think about that. Think about different kinds of forces that you know. And think what could be holding those together.
That's the opposite charges. Yeah.
I'm going to give you one that I think is probably a bad choice. How about gravitational force? You think it's the force of gravity that's holding those together?
Like the large objects, not the small.
Yeah, large objects are affected by gravity, but small objects, really the masses are too small to have much in the way of that. What are some other forces that we know about? Yeah. There's a strong nuclear force, yes. Weak nuclear force. And electromagnetism. So the deal is with these, we're not inside the nucleus, so we don't have to worry about the strong nuclear force and the weak nuclear force. In fact, you will probably not deal with those unless you go on to take a post-secondary degree in physics, okay? But we do know about electric forces and magnetic forces. Which one do you think is happening between these, say the silver and the chloride?
No, I mean, like.
What do you know about this metal? It is positive, right? And what do we know about the non-metal? It is negative. So when they form a compound, one of them has given electrons to the other, and so one is positive and one is negative. What do positive and negative do? They attract. So it is that electric force, we actually call it an electrostatic force, that holds them together.
Okay, so to learn more about ionic bonds, we are going to focus on a chemical called sodium chloride. Sodium chloride is a fancy scientific name for table salt. It's the stuff that you put on your food. So sodium chloride is made of two types of atoms. We got sodium. Here's its symbol from the periodic table, and here is a sodium atom right here. And sodium chloride is also made of chlorine or chloride. I'll tell you what the difference between those is in a minute, but you don't have to worry about it right now. And here is here's a chlorine atom. Now, sodium chloride happens when these two atoms come together, when they're glued together by ionic bonds. But the atoms that I have right here, they're not glued together. They're just kicking it over here. They have nothing to do with each other. So I want to talk about what happens to get these separate atoms connected and glued together, like these. How we go from this to this. I'm going to tell you the kicker. I'm going to tell you the end of the story now so you can follow it through as we talk. The reason why these two atoms are connected is because they end up getting electrical charges. Okay, this atom is going to end up getting a negative charge, and this atom is going to end up getting a positive charge. What do oppositely charged things like to do? They like to attract. And so because these things get different electrical charges, they are going to be held together by those different charges attracting. Okay, so let's look at the steps that we have to take to go from this to this. The first step is pretty much what I got right here. We're starting with two separate atoms that aren't connected. We got the metal atom, the sodium here, and the non-metal atom, the chlorine, over here. Now the first thing that happens on the road to an ionic bond is that the sodium atom gives one of its electrons to the chlorine atom. Here's the...
Okay, so you can fill that in. What does the sodium do? It gives an electron. Who does sodium give an electron to? Sodium gives away the electron. Who takes it? Chlorine.
The electron moving between the two of them from the sodium to the chlorine.
And what charge are electrons? They are negative. So we're taking negative away from the sodium and we're putting it onto the chlorine.
Now this electron moving, will change the charges of these two atoms. Okay? That's what happens in the next step. Sodium gives away one of its electrons to the chlorine, so it loses one electron. It has one fewer electron, and that's going to give it a positive charge because it lost an electron. But chlorine gained one of the electrons from sodium, so it's going to become negative. It's going to get a negative charge because of that extra electron. So now, these two atoms take on electrical charges. And what do we call atoms that have charges?
What do we call atoms that have charges? It's another I word. Ions, yes. Okay, isotopes have different numbers of neutrons from each other. Ions are where we've either added in electrons or we've taken away electrons. Okay, so you can fill in this little bit here. The atoms get a charge and become ions. And then underneath the little positive, there's a box. You can fill it in, lost one electron. And under the negative, again, there's a little box. You can fill it in, gained one electron.
We call them ions. This one's a positive ion, sodium becomes positive, chlorine becomes negative. Now here's where the difference between chlorine and chloride comes. Chlorine is what we call the chlorine atom when it's neutral. So up here, this non-metal atom chlorine just hanging out here is chlorine, zero charge. But down here, after it's received one of the electrons from sodium, it gets a negative charge. It becomes a negative ion. And now we change its name just a little bit. We call it chloride. So it's the same atom, chlorine and chloride. They're the same atom. It's just chlorine is the version of chlorine with a neutral charge, zero charge. And chloride is the version of chlorine that just has a 1- charge. And it got that 1- charge because sodium gave one of its electrons to chlorine.
Okay, so we're going to pause there. You can fill in chlorine, zero charge. Okay, so up here there's a couple of boxes. You can fill in chlorine, which has no charge. And then after the electron moves from the metal to the non-metal, we have chloride, which has a -1 charge because it gained that one electron. So the atom is chlorine, the ion is chloride.
Turning it into the negative chloride. Now people often ask, why does sodium give its electron to chlorine? We'll talk about that in the next video. It's a great question.
Can you guys think of why sodium might want to give its electron to chlorine? Have a little chat about that.
Yeah.
Sodium is in group 1. How many electrons are in the outer shell of sodium, which is in group 1? 1. What does sodium want to do with that one electron?
Give the electron.
It wants to give that one electron away because that would do what to its outer shell?
Empty valence shell.
You would end up with an empty valence shell, which means now your inner shell is full. Okay? Now what about chlorine? Chlorine is in group 17. How many electrons are in the outer shell of chlorine? 7. How many is full? 8. So what would chlorine like to do? It would like to take an electron to fill up its shell. Isn't that convenient? Sodium wants to give one away, and chlorine wants to take one, right? So we have a beautiful symmetry there between those two.
But anyway, a transfer of electrons takes place between these atoms, giving this one a positive charge and this one a negative charge. And what do opposite charges like to do? they like to stick together. And so this is what we end up with. The two atoms glued together because their opposite charges are holding them together. Okay, so there are really three important steps in an ionic bond forming. For the example of sodium chloride, here's what they are. The first step is an electron transfers from sodium to chlorine. Sodium gives one of its electrons to chlorine. Sodium loses an electron, so that gives it a positive charge. This becomes positive. And chlorine, because it has gotten an extra electron, gets a negative charge. And they both turn into ions, atoms with a charge. And since chlorine became negative, we call it chloride. And then the last step after the ions form is that the oppositely charged atoms, stick together because of their opposite charges. So it's those opposite charges that form that are the glue holding the atoms together.
Okay, so we're just going to pause there to let you fill in that last blank if you haven't done it already. Ions have opposite charges, so they stick together. And we are now going to bop back here because there's a few things that I added to this video, okay? Or sorry, not to this video, to this page. So on page 20, at the bottom of the page, you'll notice that we mentioned two other types of bonds. So how many types of bonds are we learning about? In this video, what type of bond did we learn about? Ionic bonds. What are the two other types of bonds that exist? We have covalent bonds and we have metallic bonds. So three types of bonds. 1, 2, 3. Ionic bonds are between what? Metals and non-metal. I'd like you to take a guess as to what metallic bonds are between. Metal and metal. Shocking, yes? Metallic bonds are between a metal and a metal. So that name really makes a lot of sense. What do you think covalent bonds are between? I think we've only got one option left. Non-metal plus non-metal. And we're not learning about covalent bonds today. We're not learning about metallic bonds today. Covalent bonds will come later in this unit. Metallic bonds we'll deal with in our electricity unit because it really relates to how electricity flows through a wire. Okay? Now, guess what? Not just any old metal, but the metal is a cation. And the non-metal is an ion. So ionic bonds form between, guess what? Ions. Yes? Ionic bonds form between ions. Metallic bonds form between metals and metals. So the real definition then of an ionic bond we have on our next page. Okay. Okay, so on page 21, we have this ionic bond. And it is the attractive force. All bonds are due to forces. It is the attractive force between the positive ion and the negative ion. That's literally what an ionic bond is. It's because those two are attracted to each other. It's like when you have a north pole of a magnet and a south pole of a magnet, they just stick together. I'm going to give you guys, there's 10 questions. I'm going to give you 10 minutes to work on this, and then we're going to watch the second video. Okay? So take 10 minutes to try and answer the questions on pages 21 and 22. If you finish those, you can backtrack. If you didn't finish those, and if you're finished all of that already, you can kind of go back to stuff we didn't cover yet on pages, I think it's 7 and 8, something like that. 5, 6, 7, 8. Yeah.
So non-metal become metals become additional. Oh, okay. So what is the compound? Beneath the eye.
Oh.
Non-metals.
Oh.
Lithium.
Oh, that's so super exciting.
I don't remember. Bromine.
Yeah, I think you would have been.
Oh, yeah, it's bromine. Bromine. And then barium 4. Oh, I swear my little brother's like no, but like staring at it, like just repeatedly staring at it, like gave me a decent amount. Yeah, same. Like, I
So
know.
you're actually going to make a compound, so rather than calcium and chloride, it's saying calcium chloride. Yes.
You, right?
Yes, yes, it would. No, the two don't go there. And the reason
Ionic bromine. I keep thinking of flower. Yeah.
Because here's what happens. You've got calcium. It's got two electrons, right? It's calcium. Now chlorine only wants one. Right? It's got one. So calcium is going to give its electron to chlorine. That makes this chlorine happy and stable. But calcium still has another electron. So another little chlorine atom is going to come along with a hole in its shell. And calcium needs the second electron. So there's two chloride and one calcium. And when you're done this long enough, you don't have to think about it to know that it's CaCl. Which sounds weird, but it's not. It's just
I'm not getting it.
Bro, I'm so baby. 14. So you guys are
Bro, like, seriously, I'm so lazy.
now, right? I've been doing this since I was in grade 9, and now I'm just grade 2. So that ultimately, like 38 years. 38 years. So more than twice as long as you have been alive.
I got you. I'm just like.
So the fact for me to just know that alkaline chloride is CaCl2 seems more normal. Right?
Yeah, what do you think? Like, it's like stop it. Bro, like, it's like so random. It's like years or like random.
Okay.
I'm skipping that. I don't have so many articles. This is wait, isn't this like lithium? That's the dude in it. No wonder. But isn't it just fine? Right, remember. No, it's lithium plus. Lithium's a metal, so it comes down.
Yeah.
But it's not lithium. It is lithium. Wait, oh yeah, what's the lithium? Yeah. Then I did fluoride, which becomes a zombie. Wait, so they want the gamer.
I was like, that was like,
What's the blue?
oh, did you find it?
Yeah, I'm gonna It's like so. No. Yeah. Your brother. Him and his friend. His friend is like a history and math. My brother's like a
Just saying, it would have been great.
so then like they like carry each other. Wait, your brother was
Where are you?
yeah,
Excellent.
I have like
Nice.
but like
Yeah.
oh yeah, and then it was really stupid was there was a history. It was like it was the leader of the USSR.
So, like, if you
The
have
friendly
two
people
men,
actually, you know,
they'll either go.
oh my
Together,
like
or they'll be like, try and push them together.
are they like really that not
Yeah.
interested?
Yeah.
You don't read the history book. Like it's like like looking at a coin. I just search on
Okay, so for these ones.
wait, it doesn't want to end up the Ionic bond thing. Oh, it would be really funny if I infiltrated my little brother's school. It's not based off one. It'd be like this.
Yeah. So, here it is. Okay. I'll be right to you. They're all those. Oh, would you get told? No, I'll do
But no, but like, should I try and infiltrate my little brother's school? Ryan, I would expect something from you. You could probably make your brother better. You? Oh, okay. Someone that is like Mr. You know what you should do? You know how like my little wait, which
Okay.
which oh wait, you too? Yeah. So John is John. No, he has 10. Born. We got bored in my class. Imagine not having one eighth long friendship with he has 10 in Rich.
I do.
But you have 10 in Rich for.
Oh yeah, I have friends with Danny.
Damn, that's pretty. Yeah, you have friends with Daniel. I don't know who I had. No, I wanted you to be my class.
No, I he was the one that I think.
What?
I do it on my computer.
Wait, why did you destroy the line?
Well, you don't look at just one either.
Yo, but no way. So I'm neighbor. Yo, I'm gonna be.
I don't really know.
That's like insane. So they formed this thing.
I can find you periodic table.
And this makes sense.
I'll be right with you. I just need to grab a couple periodic tables.
Wait, Ken, what do you do? Why do you
There we go.
No, I'm kidding. Wait, you know that's more than me, right? Lit the not right. Lit the no, but like the no, what can they? Yeah, it says lithium chloride. It's an inorganic compound chemical formula. Colorless solid that transitions to white with decreasing resistance. Although odorless, lithium chloride has a better cellular structure is analogous to this. And that means sodium chloride, but it's much less soluble in water. See, we just made a yeah. Oh, it's similar to sodium chloride, but just less. Same thing. I didn't even read that. I was just reading. Yeah, same. Guys, just go on track. But where does it say between lithium and fluoride? But where does it say in the instructions? Number 3. What do you mean? Part of where? You're on 24. You monk. Yeah, you do number 22.
Alrighty.
22? Yeah. We watched the video of Charlie and I, so we just did everything. Oh, you watched the video? You cannot let these, you cannot let these casuals. Nah, whatever. Go. Go.
Yeah.
Get it up. Very good. Whatever. I don't care. I don't care what they do. It's okay. Leave it. Let's watch it in class. He said if these guys are going to go way too out bad, they're not going to know anything. Yeah. If we go like one, right? Let's be on fluoride. Right? Yeah, exactly what I'm sure Well, I need to see maybe I can somewhere from well, so it's the Ionic.
Yes. Yes, exactly.
I'm like making entire plans for summer school already. If I'm like you're making plans. My mom will make plans for me. Your mom is saying not to do it. My mom is saying to do it. I'm saying do not to do it.
Just a second, Tristan.
My brother.
So,
Make sure you have some fun. Like 170 training. But apparently a lot of in algebra we had a 170. And guess what? That was in the United States. Like when it came here, the grades like for algebra what thousand three hundred seventy?
okay.
Yes, perfect score everywhere. You got a 100 on the so what?
Yeah, and did you see the message Dino keeps sending it to the server?
Yeah, it's telling me now you
Combined total IQ.
yeah, it's like I
No, it's not.
no, we all have zero, bro.
It was actually
No, I have 787 points. No, I have this. I want to make sure I have 7 points. How do you do 7 You look like 7 points down.
Good.
No, he looks like
Zero.
he looks like the old. He looks like a 1.
No, he looks like that was kind of zero. Okay, zero was like a line 8 like that.
No, he looks like the 1.
We're describing finding the one.
No, he looks like the. He looks like the.
He looks like 11. He looks like 11.
1 to the power of 0. He looks like the 1 to the power of 0. 1 is the 1 and the 0 is like the exponent. The head.
No, he looks like 110 likes at 11 and then 0.
Oh, yeah. No, he's not.
He looks like a happy face. Look, he looks like this.
No, 1 to the power of 0.
It looks like
No, like this. 1.1.
1.1.
Wait, that's you, bro. Your power has one so bad. What if you power from one to one? Like, let's just all walk. And then the zero.
Yes, no, hold on.
That's like you divided by one of zero. Yeah, you got this zero divided by one.
And then you and get the body like
I will take away your pencil. Do it. No, I was gonna say something else.
wrong. 3, 2, 1. Oh my god. Everyone's back in the lunch. Yes. It's going good. You do the cat. I do the cat. Oh yeah, that's I'm pretty sure that's not there. You don't have the box in the other.
I'm gonna do the white out. When you guys on it, white out. It's like
We are going to go to now 3.2b, which is, why is that not working? Page 23. 23. Page 23.
It's back with this is like so scary.
Okay.
Let's talk about ionic bonding in much more depth. In the previous video, we talked about the basic fundamentals of how ionic bonds get made in sodium chloride.
Okay, so this is just a review of what we saw a couple minutes ago, and it'll be over soon, and then we'll get into the new stuff. If you have your phone out, you need to put it away. It's a calculator. Okay, good.
Now, I want to look at why and how these steps happen during the formation of ionic bonds. In order to really understand what's going on in ionic bonding, we have to take a look at the individual electrons that live in sodium and live in chlorine. Now, as you probably know, there are specific places in an atom where electrons can live. Okay, I have a diagram of this here. If this is new, you should check out my video called.
Now we're just going to pause for a second here because you'll notice that Tyler does not pair up his electrons. Okay, the reason I have you pair your electrons is because it is a better representation of what the next model will be when you get to, say, grade 11 and you learn the next model, okay? But a lot of people just draw their Bohr models without pairing the electrons. So we will, John and Milan, you guys need to be quiet. Okay. So, we're going to forgive Tyler for not pairing his electrons. It is something that sometimes people don't do. I just like to do it because it takes you to the next step better. Okay?
Called valence electrons in the periodic table. Anyway, each one of these little circles represents a spot that an electron can live in an atom. And you'll see that these little electron spots are arranged in rings around the nucleus of the atom. Each one of these rings is called a shell or an energy level. Okay? So we can use this diagram to figure out where the electrons live in sodium and where they live in chlorine. Okay? First thing we got to do is we got to find out how many electrons there are in these two atoms. Okay. Now, sodium here, you look it up on the periodic table, it's got this 11 here. That means it has an atomic number of 11. There are 11 protons in sodium. Now remember, when ionic bonding starts, these atoms are not yet ions. They don't have a charge. They're neutral. So that means that they have the same number of protons and electrons. So there are 11 protons in a sodium atom. That means there are also 11 electrons in a sodium atom.
Hopefully none of this is new. This is all just kind of review. Atomic number 11, 11 protons, 11 electrons.
Okay, the same thing is true with chlorine. It has an atomic number of 17, 17 protons. It's starting out without a charge, so it has 17 protons and 17 electrons.
Okay, and I think there's space for you to write that in, or is it already written for you? Let's take a look. Yep, you can write those in. And also at the top of the page, I didn't pause because I was busy glaring at people. Every atom wants to have what? A full or empty valence shell. So I'll just, this is 154, we'll just back up for a minute. No, can't find it, that's okay. 154, all right, there. Okay.
We can take one of these diagrams and fill it in from the center on out with a number of electrons. So for sodium, that's going to look like this. 11 electrons arranged around the atom from the center out. And for chlorine, it's going to look like this. 17 electrons arranged around this from the center out. Now you may not be able to tell from these diagrams, but these are two very unhappy atoms. The reason why has to do with their valence shells. You remember what valence shells are? They are the furthest out energy level that still has electrons in it. Okay, so for example, this is the valence shell of sodium. It's got one electron here. And this is the valence shell, the furthest out shell for chlorine. Okay? The reason why these two atoms are so pissed off is because every atom wants to have a full valence shell. It's like every atom's goal in life. Sodium is really unhappy because it only has one electron in its valence shell, and it has these 7 empty spots. Okay? Chlorine, on the other hand, is also upset because it's got a mostly full valence shell, but it's got one empty spot. It's so close. It's so close, but it's still super unhappy because the valence shell isn't full. So sodium and chlorine are both unhappy. They both want to fix their situation. And in trying to fix it, that is how they're going to end up with an ionic bond. Okay, so how are sodium and chlorine going to get happier? How are they going to fix their situation? How are they going to try to fill their valence shells? Well, take a look at this. They can help each other out, okay? Chlorine has one spot left before it's able to fill its valence shell. And so what happens is sodium can give chlorine one of its electrons, okay? So this electron moves from sodium to chlorine to fill this spot. Here's what we end up with. Okay, let me just show you what's going on here. Okay, so we got sodium, we got chlorine, and this electron up here moves between them. Okay, so it leaves sodium and it goes into chlorine. Okay, and now chlorine has filled this empty spot with one of sodium's electrons. Okay, so now chlorine is super happy. It has a full valence shell. It's achieved its goal in life. But take a look at sodium over here. Though you may not know it, sodium has also achieved its goal in life. Because when it gave this one electron, when it gave the electron to chlorine, it totally emptied out this valence shell. Now you might think, okay, that made it even worse because now it has 8 empty spots it has to fill. But here's the thing. If you can get rid of all of the electrons in your valence shell, it's like that valence shell just disappears. Sodium doesn't even have to worry about it anymore. Okay, so it gave away this last electron in its valence shell, and now it's like the valence shell just disappears. And this is now sodium's new valence shell. And check it out. It's totally full. So by giving away that one electron, it could get rid of its whole outer shell, and this is its new valence shell. It's full, and sodium's happy. So this is what we end up with. Let me just show you what the intermediate steps look like here. And this is what it looks like when sodium gave it away, and we can sort of think about it still having this outer shell. And here is chlorine with the new electron from sodium. So we've got step 1, step 2, step 3. Okay, so now chlorine has a full valence shell. Now sodium got rid of its old valence shell, and its new valence shell is totally full. They're happy. But let's talk about what's going on with the electrons here, okay? Because there are electrons moving. Now, over here with chlorine, it used to have 17 electrons, and then it got a new electron from sodium.
How many electrons does chlorine have now? 18. And how many electrons does sodium have left? 10. Excellent.
So it doesn't have 17 electrons anymore. Now it has an extra one, so it has 18 electrons. But it has the same number of protons because we weren't moving protons in this example. Okay? So it's still got 17 protons, and it's got 18 electrons. But now there's an imbalance between the number of protons and electrons. It doesn't have the same number of protons and electrons anymore. It has more electrons, which means that it has a negative charge. It has a negative charge of 1 minus because it has one more electron that it got from sodium. And now we can call it an ion. Now, sodium also became an ion, right? It used to have 11 protons and 11 electrons, the same amount, so it used to be neutral. But not anymore, because it gave away one of those electrons, so now it only has 10. But it's still got the same number of protons. It's got 11 protons with positive charge, and it's got more protons and electrons. One more proton. And that means it's going to have a positive charge, okay? It's going to have a 1 plus net charge, and it also is going to be an ion, an atom with a charge. So this guy over here has a 1 minus charge. This guy over here has a 1 plus charge. Now, as we've said before, they have opposite charges, so we could maybe kind of zoom out a little bit. Take a look at what these atoms are going to look like. Here we've got a chloride with a negative charge. We've got sodium with a positive charge, and they're going to stick together, just like we've shown here. And that is because opposite charges attract. We have the...
Okay, so I'm just going to pause it there so that you can fill in everything that needs filling in. So if you didn't have a chance to fill in the 11 protons and 11 electrons, you can do that. 17 protons, 17 electrons. And atoms want what? Full valence shells. Then we get the transfer of the electron from the sodium to the chloride. So we still have 11 protons, but now we have 10 electrons. That's 11 positives and 10 negatives. And that gives us, means we have one more positive than negative, which gives us a +1 charge. The chloride still has 17 protons, but it gained 1 electron. So it's got one more negative than positive, so its overall charge is -1. And then once you have that positive and negative, the opposite charges attract. Okay? And that basically takes us to the end of this video. I don't know what he says after this, but we don't need very much. So your homework, most of it, we've still got 10 minutes left. You might even be able to finish it in class. Some of you might have finished it already. Pages 12, 16 to 17, 21 to 22, and 24. If you didn't finish it in class, that's okay. You've got 3 days over the weekend to do it. It should be all right. Okay?
Oh, this one, I mean, we can do for the blonde. Nah, I'm gonna go off. Oh yeah, same now. Wait, it says between.
Positively charged sodium.
Okay. There we go.